In part A and B, the last child in the line, being the farthest away from the axis of rotation, has the greatest radial acceleration. The force needed to produce this acceleration is provided by the pull of the rest of the children in the line. It won't take long before this acceleration becomes too high, especially for the final two children in the line. At this point, those children will not be able to apply enough force to hold on and will have to let go. In part A, a small metal cylinder rests on a circular turntable that is rotating at a constant rate. In this question in part A is the E because vectors F and A are directed downward and vector B is directed to the right. And in part B, the speed of the cylinder has decreased and the magnitude of the acceleration of the cylinder has decreased.
A merry-go-round makes 27 revolutions in a 30.2 mean ride. The revolutions and minutes in a merry-go-round are given 27 and 3.2. Angular speed is requested. We use the frequency formula of revolution divided by time in seconds. Once we have it, we use the angular speed formula, which is equal to 2 times pi times the frequency already calculated. We do the operation and the result is 0.88 rads divided by seconds. Rads per second, sorry. B. Tangential speed is requested given the radius of two people. We just need to multiply the radius times the angular speed to get the tangential speed. Problem 4, stage 3. The driver of car sets the cruise control and ties the steering wheel so that the car travels at a uniform speed of 15 meters per second in a circle with a diameter of 150 meters. Part A and Part B. The speed and diameter of car is given 15,150 and the time of 4.5 minutes. Angular distance, we use the formula of angular speed equals angular distance divided by time. Angular distance is isolated and the angular speed is multiplied by the t in seconds. The angular speed is calculated by using the frequency of the car's tires.
This is the problem 5 and 6 of stage 3. Well, in this problem, I use the formula velocity is equal to square root gravity per radio. And this is velocity is equal square root 9.81 per 1.2. And this equal 3.4. Okay, this is the problem 6. In the part A, I use the formula 45 RPM is equal 1 over 60, and this equal 0.75. And then I use the formula angular velocity is equal to pi where 0.75 is equal 4.71. And the part B, I use the formula frequency is equal angular velocity over 2 pi, and this is equal 0.74. And then I use the formula the 1 over frequency is equal 1.33.
Problem 7, stage 3. To start, you must get the angular velocity, which will have to be multiplied by the number of revolutions per minute, which in my case is 1900, by 2 pi and divided that by 60, which will be equal to 199 radians per second. Then for part B, you should get the number of radians what the angle equals. Here is to multiply 40, what is the angle that gives us, by pi, and then divide it by 180. That will then be divided by the amount of angular velocity that the question gave us in the last part, giving 3.51 by 10 to the negative 3. For the part C, you must multiply the number of radians that the question gives you, which in my case is 21, by 60, and divide it by 2 pi, which is equal to 201 revolutions per minute. And finally, for the part D, to get the period, you must divide 2 pi between the 21 radians. It will be equal to 0.299 seconds.
So, for stage 3, I solved the problem number 8, and this problem says that I need to take out the frequency of a second hand of a wall clock. Okay, so I use the formula of the frequency, which is 1 divided by the period, which gives me 1.67 times 10 to the power of negative 2. Then I find the angular frequency of the second hand of the wall clock, which is the angular velocity is equal to 2 times p times pi times the frequency, which gives me 0.105 rad divided by seconds. In the part C, it says me to find the frequency of the minute hand of a wall clock. I used the formula of the frequency again, and it gives me 2.78 times 4 to the power of negative 4. Then I find the angular velocity of it, and it gave me 1.75 times 10 to the negative 3. And this was all the problem.
Step 3, problem 9. This problem we need to find the radius of a corner through which a car will go around and make use of centripetal acceleration. The formula is acceleration equals velocity squared divided by radius. To substitute this formula, you will have to write what radius is equal. You have to write what radius is equal to the velocity squared divided by the acceleration, will give us 40 squared divided by 4.2, obtaining as a result the 47 meters of the radius. Stage 3, problem 10. For this problem, we must join the acceleration caused by centrifugal structure with the acceleration of the Earth, doing this 9.8 times 9, equaling 88.2. Then we can go to the centripetal acceleration formula, that is velocity squared divided by the radius For this has to be substituted for what will be the square velocity. It will pass as velocity and will be equal to the square root of the acceleration times the radius, giving a total of 366.37. Stage 3, problem 11. Here, the formula of acceleration will be used, which is equal to the angular velocity squared times the radius. Just now we will substitute the acceleration. Will be considered gravity. Then it will be equal to 9.8. The substitution of the formula will remain as angular velocity equal to the square root of 9.8 times 2 divided by 7,600, giving the answer 5.1 times 10 to the negative 2.
Okay, now to end with the stage 3, we're going to see the last 3 problems, 12, 13, and 14. And starting with 12, it says, 1,300 kilograms car drives a flat and 200 meters diameter circular track at 20 meters per second. Okay, so we can get the following data, that is that the mass is equal to 1,300, diameter is 200 meters, but we will use radius, so 100 meters, and velocity is equal to 20 meters per second. And part A is asking us for a net force. Net force can be calculated with the following formula. Mass times centripetal acceleration. But we don't have a centripetal acceleration, but we can get it with this formula. That is velocity to the square over r. So this will give us 20 to the square over radius. And this will give us 4 as a result. And now we just have to multiply, mass, that is 1,300 times 4. And this will give us 5,200 newtons as a result. Now part B asks us what is the direction of the net force on the car. Net force can be also centripetal force. So it is that the net force points to the center of the circle because net force always points to the center of the circle. Now going with problem 13. It says, in the Bohr model of the hydrogen atom, an electron, and it says the mass, orbits a proton at a distance of 5.3 times 10 elevated to the minus 11 meters. The proton pulls on the electron with an electric force of 8.2 times 10 elevated to the minus 8 Newton. Part 8 is asking us the revolution per of the electron. So it is asking us for frequency. We have here force, that is this. We have also mass. And we have also the radius. That is 5.3 times 10 to the minus 11. With this information, we can get acceleration, for example, because we know this formula. So we just have to do this to get the acceleration that will be important for us later on the search of the frequency. So doing this calculation, we will get as a result 9.01 times 10 to the 22. Now we know that acceleration can be represented by this. And we want to know W in order to search the frequency. So we will get square root of acceleration over radius. So we will do 9.01 times 10 to the 22 over the radius that is 5.3 and times 10 to the minus 11, and this is and I'm sorry, this is 9.01 times 10 to the 22 over 5.3 times 10 to the minus 11. This will give us 4.2123 to the 16th. And with this, we know that the formula of W is also 2 times P times frequency. So we search for frequency, so it will be W over 2P, and 4.123 elevated to the 16th over 2P give us 6.56 times 10 to the 15th power. And this is the result that we got here. So now going to the last problem, the 14, I'm sorry, it asks us, it says, rank these objects in order of increasing centripetal force. Indicate ties where appropriate. We have the data there, and they are asking us to rank from largest to smallest the centripetal force of each. So first we are going to calculate letter A force that we see there that we have mass, speed, and radius. With this, we can calculate acceleration, velocity squared over radius, that will be 1 to the square, 1 to the square over 5, and this will be 0.2, and this 0.2 will be 0.2, that is the acceleration that we got, times the mass, that in this case is 60. So force of A will be 12. Now we're going to calculate the force for B using the same process. Will be 2 to the square over 2. That will be 2. Oh, wait, I'm sorry. That it will be mass is 5 times 2. Force of B is 10. Now letter C. Letter C, and acceleration will be equal to 2 to the square over 8. That will be 0.5, and it will be 0.5 times 24, that is the mass. That is going to be 12 also. And now finally, the letter D has a speed of 4 and a radius of 1, so it will be like this, and it will be 16. And now force can be calculated by that, with that 16 times the mass, that is 2. So as we can see, the bigger was letter D. The bigger was letter D, as we see here. Then letter A, that was 12, and letter C, that was also 12, were in a tie, and letter B was the last with 10. So with this, we conclude all the problems of stage 3.